Hi there, today we're going to be talking about complementary, supplementary, and vertical angles. So let's go ahead and get started with complementary. Complementary angles, and this is best described using a diagram, are two angles that form a right angle. So if I have a right angle, a pair of complementary, now it's more than one angle, so a pair of complementary angles would be angle 1 and angle 2 marked on this diagram that add together to give me 180, to give me 90. Two angles that add to 90 degrees. And if someone ever asks for a complement, not a compliment like, hey, yeah, you look pretty, but a complement to 30 degrees, they're saying, what do I add to get to 90 degrees? So if you ever see the words, what is a complement to 30 degrees? The question really is, what do I add to get to 90 degrees? So the complement to 30 degrees is, well, what is 90 minus 30? And that will tell me 60 degrees. So the complement to 30 is 60 degrees. Supplementary, two angles that add to 180 degrees. So what does 180 degrees look like as a picture? Remember, 180 is a straight angle or a straight line. Now, if it's two angles that make up a straight line, then I'm going to have, for example, angle 1 and angle 2 that go all the way from one edge of the line to the other. And if similar to complements, you might see, what is a supplement to 100 degrees? And what that's translated into is, what do I add to get to 180? And how do I figure that out? Well, 180 minus 100 gives me a total of 80 degrees. So 80 and 100 are supplements. So let's go ahead and look at a few problems that are going to be similar to what you see on the homework assignment. Okay, so this is following up with the question that we just asked. What the angle measures 33 degrees. What is the measure of its supplement? So in other words, what do I add to get? Now, supplement 180, complement 90 degrees. That's just something we got to memorize. So what do I add to get 180? Well, take my calculator, 180 minus 33. My supplement is 147. The angle measures 40. What is the measure of its complement? What do I add to get to 90 degrees? So I take 90 minus 40, and that gives me 50. To continue, let's look at a different example. So I'm going to look at the diagram and ask myself what I've got going on here. And then I gotta read the instructions as well. So as I look at the picture, I can see that it's marked with a 90-degree angle. So that's what I'm looking at so far. And then it says in the figure, the measure of angle 1, that's what the little m stands for, the measure of angle 1 is 2x degrees. So I'm going to come in here and I'm going to mark this is 2x degrees. And the measure of angle 2 is x plus 33 degrees. So all of what all those words were is showing this picture right here. Now question A says, write an equation to find x and make sure to use an equal sign in your answer. So if I'm writing an equation, I need to know two things that are, remember, two things that are equal to each other. Well, I know that this the combination of these two angles is equal to 90. So I'm going to start by saying I know that 90 is equal to angle 1 and angle 2. I'm going to write a preliminary equation. 90 equals angle 1 plus angle 2. Now I can't just leave it as angle 1 plus angle 2. I need to use that equation to find x. So I need to have x in my equation. So I'm going to go to my equation, find angle 1. Angle 1 is 2x. And I'm going to add to it, so I'm going to add angle 2. So plus, go find angle 2 in our diagram, x plus 33. Or you can find angle 1 and angle 2 up here. So that would be the equation that I would write. Done. Now it says, find the degree measure of each angle. Well, I don't know how big that angle is. It says 2x. If I can figure out what x is, I can use that to figure out how big this angle is. So let's work on finding x. That requires solving an equation. So remember, anytime you solve an equation, and I encourage you to write out our equation and solve this with me, I'm going to draw a line down my equal sign, and then I am going to solve. So I'm going to combine everything I can on both sides. 90 is as simple as I can make it, but if I look over here, I see that I've got 2x. Remember, this is a imaginary 1 in front of that x. And those are two terms that I can combine because they both have x's. 2 plus 1 is 3, and I bring the x along to the right. Plus 33. That doesn't have a like term on this side of the equation, up this side of the line, so I bring it down. I bring down everything else, including my equal sign and my 90. And now that both sides are simplified, I'm going to isolate the x. Remember to find, to get rid of whatever's furthest from the x to begin with, and that's this 33 over here. Notice that it's adding 33. Remember, when we solve equations, we use inverse operations. So I'm going to undo addition with subtraction. So subtract 33. If I do it on one side of the line, I do it on the other. So subtract 33, and 90 minus 33 is 57. So 57 is equal to 3x. How do you undo this operation right here? Right here? Well, what operation's going on? It's multiplication. So undo it with division. 57 divided by 3 is 19. X equals 19. Now that gives me what x is, but remember that doesn't tell me what angle 1 and angle 2 are. I'm going to go back to my diagram. If x equals 19, I'm going to insert that into my diagram right where that x goes, and I'm going to replace, whenever I replace x, I put the number in parentheses. So 2 times 19 gives me this angle, so 38. Angle 1 is equal to 38 degrees. Angle 2, I'm going to replace x with 19, so 19 plus 33. 19 plus 33 is 52. And as a way to check my work, remember angle 1 and angle 2 should equal 90. Does 52 plus 38 equal 90? 38 plus 52, and yes it does. So we are good to go. Alright, similar things can be done with straight angles. Notice I have a straight angle right here. That's equal to 180 degrees. I always label my information so I know what I've got going on. It asks me to find the angle of measure of angle 1 and number 2. So come up here. Well, measure of angle 1, I'm going to draw it in my diagram. I like to do that. And 2 is x minus 18. There's an x. I need to figure out what x is so I can figure out how big angle 1 is. Well, how do I do that? I'm going to take these two steps that I did on this previous problem. I'm going to write an equation. This time, since my diagram is a total of 180 degrees, I'm going to write an equation that's a total of 180 degrees. I'm going to start with 180 equals. Well, it's equal to angle 1 plus angle 2. Well, what's angle 1? 5x. Plus, well, what's angle 2? X minus 18. I'm going to draw my line down my equal sign and simplify each side. 180 is as simple as I can make it. I bring down the equal sign. I come over here, and I've got 5x plus 1x. That combines to give me 6x. And negative 18 doesn't do anything. It doesn't combine with anything because of this barrier of my equal sign. Now that I have just one x, I'm going to isolate it. I'm going to undo subtraction by addition, and I'm going to do that on both sides of my equal sign. So 180 plus 18 is 198 equals 6x. Divide by 6 because this is multiplication. 198 divided by 6 gives me 33. Now remember, I'm not just going to put 33 in these blank boxes. I need to go back to my diagram. Take this x and replace it with a 33. Now remember, when I replace it, I'm going to put it in parentheses. So 5 times 33 is 165. So 165. As I plug it into angle 2, I'm plugging in the 33. 33 minus 18 is 15 degrees. And as I check my answer and I add those together, 15 plus 165 is 180. Alright, so that's it for calculating angles of complementary and supplementary angles. We want to talk about one more thing. We want to talk about something new called vertical angles. I'm going to draw a diagram. Now, vertical angles are formed by two crossing lines. So this diagram makes a couple pairs of vertical angles, and I'm going to mark them in here. This is angle 1, angle 2, angle 3, and angle 4. Now what I want you to do is imagine if I were to take my piece of paper and fold it right here, so fold it right there, this angle 1 is going to line up perfectly with angle 3. Vertical angles have a lot to do with that line of symmetry and folding right on top of each other. So vertical angles are angles that are congruent. And we usually say that they're opposite of each other. Or across from each other. So you'll notice the angle 1 and the angle 3 aren't touching except for at their vertex. So that's another thing. They touch at the vertex, vertical, V for vertical. So angle 1 and angle 3 are vertical angles, and angle 4 and angle 2 are vertical angles. So let's go ahead and look at a diagram. And this asks me to give one pair of vertical supplementary angles and one pair of vertical angles. So as I look at this huge diagram, I notice, if I were to chop it right here, I have one pair of lines that cross, and I have two pair of lines that cross. So I've got a lot of different pairs of vertical angles. Also remember, supplementary is formed by a straight line or a straight angle. You can see I've got a lot of straight lines going on in this diagram. So I've got a lot of examples of supplementary and a lot of examples of vertical. So, but it just asked me to list one pair. So here we go, supplementary. When we find supplementary, we're looking for that straight angle. So I'm going to find one straight angle. Here, I'm going to use this line right here. Okay, what two angles, if I were to ignore everything else on this diagram, but that line, then just one side of it, okay, what two angles make up that straight angle? Angle 8 and angle 4, and that is one pair. I could do the same thing for any straight line. Okay, I could use this straight line and ignore everything else in my diagram. So what's another pair of supplementary? 1 and 5. Or I could ignore everything but this part of my straight line, and a pair of supplementary angles would be, make up that straight line, 5 and 6. And there's a lot of them, so just pick one. And remember, my vertical angles are the angles that meet at that vertex and only that vertex. And if I were to fold it on that vertex, they would be congruent, they'd line up. So remember, we're just looking at an intersection. So let's eliminate one intersection. If I were to fold on that vertex, which ones would line up on each other? So that it's up, line up on each other. So 7 and 4 meet only at that vertex. They're across from each other. So that's one pair. We only have to list one pair, but what would be another pair from this half of the diagram? 8 and 3 would also work. And if I ignored that side and just looked at this side, okay, what just meets at this vertex? 1 and 6 would be another pair. And 2 and 5 would be another pair. So that is vertical angles, and I can do that on no matter what diagram I look at. Supplementary, look for a straight line, ignore the rest. What's a pair of supplementary? Even ignore the bottom part of the line. 1 and 2. Vertical, ignore one half of that diagram. Just find one pair of lines that cross. Okay, there's two pairs of lines that cross. Find that vertex. Okay, what are two angles that meet only at that vertex? 2 and 3. All right, so my last problem. In the figure below, angle measure of 1 is 39. I'm going to draw that in here, 39 degrees. Find the angle measure of 2, 3, and 4. Okay. Now remember what I said back on this page. Vertical angles are angles that are congruent. That means they're the same size. They're equal to each other in size. So if I were to, here's my vertex and my angles, if I were to fold on this dotted line and land it straight over, okay, angles 1 and angles 3 are vertical angles, and because they fold and land perfectly on each other, I could come right in here and I could say, this angle is 39 degrees. Now how do I find angle 2 and angle 4? Well, I can tell that they're bigger than 39, but how do I go about finding out exactly how big? Well, what I'm going to do is I'm going to ignore, I'm going to notice that I have a straight line right here. Straight line. And like I said on the last time, anytime you identify that straight line, ignore what's on the other side. I have angles 1 and angles 2 that form the straight line. Remember, straight angles add to 180 degrees. So how do I find that missing angle 2? I'm going to take 180, I'm going to take away 39, and that's going to give me 141. So angle 2 is remaining 141. Now I could probably do something similar to find angle 4, except for I notice that angle 2 and angle 4 share only that vertex. If I were to fold it on this line, they would land exactly on each other. So angle 4, using, and we're going to keep using that vocabulary, vertical angles, is also 141. So let's list these out. Angle 2 was 141, angle 3 was 39, and angle 4 was 141. All right. If you have any questions, please reach out and have a great day.